Before starting this video, I want to let you guys know that Coding Cleverly also has a Patreon page. So go to patreon.com/codingcleverly and you'll see that there is a Patreon page that is available, and you guys could support the channel by just joining any one of these tiers. You guys also could become my patrons. That would also motivate me to provide better and better content. So all you got to do is go to this page and show some love to Coding Cleverly. Enough with the shameless plug. Now let's go to the video. What's up guys, welcome to another video. Today we're going to be talking about stacks. Before talking about stacks, I wanted to show you that I have my linklist.java file here. I have my node.java file present here as well. So you could be guessing that I'm going to be using these structures inside of my stack. So we're going to try to create a stack from the ground up. So if you didn't watch my link list or node video, I would encourage you to first watch that. And if you have a good understanding of that, then definitely come here and make some stacks. If you guys already know linked list and nodes, then it's perfect for you. This video is perfect. So the first thing is that we have a linked list. We discovered we have a head, and once we create a linked list, the head is set to null. We have the add to head method, add to tail method, which adds to the tail, adds to the head. I'm not going into detail for this. I've already done this in my earlier videos. Remove head will remove the head from the linked list. The toString method will just actually print out the list in its order. The node.java class, on the other hand, has a data, next, and previous. These are just pointers. This is a data. It's in string format. Once we create one, we sign the data with what we have, and we set the next to null, meaning that this is actually a singly linked list. And now what we have here is that we have a set next node, we have a previous node, we have a get next node, get previous node, all the basic stuff here. And now let's go to the stack. Now, stack contains data nodes, and you could support three main operations on the stack. One is the push, which adds data to the top of the stack. Pop, which removes the data from the top of the stack. Peek, which reveals the data on the top of the stack. This is our empty stack. Once we add something in the stack, it's going to go on the bottom. So here we have our first element. If we want to add another one, we'll have to add it on the top of here. So now this is two elements here. So the element, the method that allows us to add stuff to our stack is called the push, which adds the data to the top of the stack. So we can say push another one, and there you go, another one came. Push another one, and another one came. And we could also pop stuff, and that removes the data from the top of the stack. So this is pop again, and we just left with one. We don't want to pop that, then we'll have nothing left. But this is the pop operation. The peek, on the other hand, reveals data on the top of the stack. So if I peek right now, I could see that this container, I could see, and whatever data it has, I'll be able to access it. Stacks can have a limited size, and pushing data onto a full stack, which is limited, will result in a stack overflow. So the way stacks process data is last in, first out. Last in, first out, meaning we put some data here. Suppose we have one more. So push, two, push one more. There you go. We got 4 items here on the stack. Now, if I want to talk about the process here, we have the LIFO, which is last in, first out. So this was the last one in, but we're actually pushing that one out for the first one. So last in, and it's first one out. And then last in, this was the most last in, the most recently pushed in, and that would be the first one that's going to be out. This one in, and this is going to be one out. So this is how the stack works. In our case, we're going to use our handy linked list for our stack, and we're going to use these nodes as our data elements. Here we have 4 variables. We have the stack, which is the linked list, size, which is an int. The default max size is the maximum value of an integer in Java. So that's going to be in a final int. Final is like a constant value, so it won't change. And then we have a public int max size, and that's the max size of the stack, the current stack that we have. And this is the size here. So now we have a constructor, and we say this, and then we have max default size. So we just get the max default size of the integer.max value. Then we create another constructor here, and we put the max size that we passed in as an input parameter. So over here we just declared it, and over here we initialized and instantiated it. the linked list, and then the size was set to 0, and the max size was the size that was passed in. Then we created some methods here. What was the first one is has space. It returns true or false depending on the situation here. If the current size is less than the max size, then it would return true. If the size is on the other hand, it would return false. Is empty returns true if the size is set to 0. Now we have a push operation, which is just adding stuff into the stack. We have the data here. If the thing has space, so the stack has space, we'll just have to say this.stack.addToHead, and where we're using the addToHead method is from here, the linked list. And now we just add the data here. That will instantiate an object for us, a node, and then that node would be from here. And then we could just increment the size from there. And then if this doesn't work, suppose if it doesn't have space, we say that the stack is full. So after this method, we have the pop method, which is to remove an item from the top of the stack. So if the stack is not empty, then we're allowed to perform this pop operation. And if the thing is already empty and you want to pop something that it doesn't make sense, just throw a stack is empty error. So throw new error and then stack is empty. This dot stack dot removed head, and removed head is also over here. There you go. And then what we do is that we just decrement the size and return the data value. So that would be popped and then else throw new. Because we're using a string return type, we have to return data. Now the peek operation was just to look at the value on the top, and that's the head, right? So we'd say something like this. So if the thing is empty, we just return null, and if it's not, then we return the this.stack.head.data. Pretty easy, pretty dope. Let me know if you thought this video was useful. Like always, I'll see you guys in the next one.